Okay, we proceed with the next topic, which is the evaluating the classification function. Okay, so from the previous lesson, you have learned how to allocate the new observation to the region R1 or R2 and so on, using the two methods, right? The two approach, which is using the classification rule and also the linear discriminant score, right? We have to approach to find the classification function and also to locate the new observation to which group, right? So we have to approach. The first approach gunakan like I said just now, classification rule, and also yang kedua kita gunakan linear discriminant score, right? So kalau if the groups is involve only two groups or two level, so we can use both approach. But if the groups is more than two, so we go to the second approach, gunakan linear discriminant score. Right? Okay, so today we want to evaluate whether the function that we create before this, that we built, is suitable or is enough or valid to use that function. Okay, we have five methods actually. So what is okay, we evaluate the classification function using the error rate. We have 5 error rate. So what is error rate? Error rate is one important way of judging the performance of any classification procedure. To calculate its error rate, or dipanggil misclassification probabilities. Okay, so kita akan kira error rate to judge the performance, to evaluate the performance of the classification procedure, and then from that we can make decision whether our classification function yang that we built before this is valid or not to use for the other data. Okay. Okay, dalam your textbook, this topic is on page 596. Okay, so for error rate, we will calculate the percentage of observations misclassified by the discriminant function. Okay, kita akan tengok berapa banyak misclassified observation that will occur when we use the discriminant function that we built tadi tu. Okay, so we have 5 error rate: optimum rate, actual error rate, apparent error rate APER, resubstitution error rate, cross validation error rate. Okay, but usually we will use the 3 error rate that we usually apply, which is the third, fourth and fifth. Okay, so but for the first one, OER adalah optimum error rate. So it is the error rate for minimum total probability of misclassification, TP ataupun TPM. Okay, so to calculate this error rate, we need to know the density function for the variable. Okay, kita tahu f1x, f2x, then we need to integrate the function. Okay, so we can calculate this OER, okay, this error rate, if only population density function are known. Kalau tak ada, if we do not know the PDF for each variables, okay, we cannot calculate this error rate. Okay, sama juga dengan actual error rate AER. We need to know the function for the for the population kita tadi ada data. So because of that, these two error rate OER and AER are not well known in our method to evaluate the performance of the classification function. We will use the APER. It is more convenience. Okay, so what is AER? It is the fraction of observations in the training sample that are misclassified by the sample classification function. The formula is this one, okay, which is N1M plus N2M divide N1 plus N2. What is all this N? Okay, we can calculate APR using the confusion matrix. This is dipanggil confusion matrix. Okay, N1C adalah N1C adalah number of items in first group correctly classified as first group item. Okay, it correctly classified. Okay, N1M here adalah number of items in group 1 misclassified as item for group 2. Okay, this is the misclassified number of misclassified items. Okay, N2M also a number of misclassified items of second group. Okay, misclassified as first group. Okay, N2C adalah number of items correctly classified, number of items in group 2 correctly classified as group 2 items. Okay, so error rate yang kita nak kira ni actually adalah the ratio of number of misclassified divide the total number of items in both group. Okay, N1 plus N2. N1 here adalah total of these two. N2 adalah total of these two. Okay. Okay, so that is the ratio, the error rate. So we want to know whether we can use the classification function that we built. It is acceptable if the error is less than 20%. So you need to change to percentage lah. Okay, so APR ni adalah actually the proportion of the items in the training set that are misclassified. Okay, so macam mana nak dapat nilai N1C ni kan, number of items that misclassified or correctly classified. Okay, how to get this? Okay, remember we built before this, we built the classification function. Let's say ada dua cara tadi sebelum ni kan, guna classification rule dan juga gunakan discriminant score. Okay, so boleh guna dua-dua. Okay, so daripada situ kan we create the function. Okay, so bila kita ada function tu, we test balik kan, we create the function using the data yang ada kan, data we have set of data. So from that we can find x1 bar, x2 bar, boleh cari s2 dan inversekan dia, masukkan dalam formula, dan you akan dapat the function kan, panggil discriminant function ataupun the classification function. So daripada situ bila kita dah ada function, kita test, kita masukkan observation setiap data yang ada x1 x2, kita replace dalam function yang that we built. Okay, daripada situ we replace, dia akan it goes to which group kan, whether it is for pi 1 or for pi 2. Okay, and then you tengok pula whether it is true that 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 data, that observation yang kita replace tadi, it is true for pi 1 or for pi 2. So from that kita boleh kira lah how many item yang misclassified, how many item yang correctly classified. So kita boleh kira kat situ N1, N1M, M2M dan N2C. So from there we can calculate the Aper, the ratio, the error rate, and then change kepada percentage. If the APER is less than 20%, so we can say that we can use this discriminant function, or we can use this classification function for the other data. Okay, itu adalah APER. Okay, this is easy to calculate using the APER rather than OER and AER. Okay, can be overcome by having very large sample size. We can use the APER juga. Okay, let's see the example. Dalam your textbook, it is on page 598, 599. Okay, consider the classification region R1 and R2 shown in figure 11.1. Okay, this figure. Okay, kan macam sebelum ni kan, before we proceed dengan kita nak allocate the newcomers to which region. So first of all, kita create ataupun draw the scatter plot of X1 versus X2. Betul tak? So daripada situ juga, jadi daripada scatter diagram ni, kita boleh tengok whether we can proceed with the discriminant analysis or not. Okay, kalau you tengok dia punya point ni, kalau point tu sekata je semua, dia blend antara black dot dengan the the white dot kat situ. Kalau dia blend sekali, so maksudnya dia tak ada discriminant langsung di antara variables. So kita suggest not to proceed dengan discriminant analysis. But kalau tengok kat sini kan, okay, the black dot berada di sebelah kiri, kebanyakannya di sebelah kiri. The white dot kebanyakannya di sebelah kanan. But adalah some of that ada overlap. So if we can see this pattern of scatter plot, we can proceed with the discriminant analysis. Okay. Okay, kata in this case, observation north east of the solid line are classified as pi 2 more honor, and the observation southwest of the solid line are classified as pi 2, which is non-honest. So kita ada dua group kat sini, honest dan non-honest. So we want to see whether the classification that we built is valid or not. Okay, notice that some observations are misclassified. Okay, the confusion matrix is given. Okay, if not given, kalau kita ada function, so we can calculate this confusion matrix. So daripada sini, from here we can see that 10 here adalah kan pi 1 pi 1. 10 here actually adalah we can see that 10 adalah honors that are correctly, okay, 10 of the honors are correctly classified as honors. Okay, sebab dia memang daripada pi 1. Okay, 2 here adalah number of 2 of the honors. Okay, 2 of the honors misclassified as non-honors. These two here, 2 of the non-honors misclassified as honors. This 10 here, 10 of the non-honors correctly classified as non-honors. Okay, with all the information, we can calculate the APER, the error rate, okay, which is the misclassified, total of the misclassified 2 plus 2 divided dengan total of the items in both groups, 12 plus 12. multiply by 100. So kita akan dapat 16.7%, which is less than 20%. So we can see that we can use the discriminant function that we have in order to classify the new observation into pi 1 or pi 2. We can use the function. Okay, so maksudnya the function is valid. The discriminant function is valid. Okay. Alright. Okay, the next one is the resubstitution error rate, and yang ke last kali cross validation error rate. Okay, you need to know the difference between these two. Okay, so resubstitution error rate adalah percentage of the observation in the training data which are misclassified by the classification function. Okay. So, nak kira resubstitution error rate, sebenarnya kita gunakan the same formula of APER, apparent error rate. Cuma, dia punya konsep sahaja, pelaksanaannya sahaja yang berbeza. Pelaksanaan nak dapatkan this confusion matrix sahaja yang berbeza. Okay, so how? Okay, untuk resubstitution error rate ni, we have the data, kan? We have the data, and then from that we create the misclassification function ataupun discriminant function. Okay, kita ada data tu. Let's say kita gunakan, we have the 30 observation. So we use this 30 observation to create the discriminant function. Okay, so kita ada discriminant function. Okay, and we also will use this data yang sama kita gunakan untuk evaluate. Okay, untuk evaluate the function. So maksudnya kita gunakan 30 data tu balik, data 30 balik untuk replace dalam function yang ada untuk create this confusion matrix. Kita gunakan this confusion matrix untuk nak evaluate the performance of the function yang kita create tadi. Kita gunakan data yang sama untuk evaluate the function. So daripada sini kita dah ada value ni, kita boleh kira APER, tengok dia punya percentage. Itu adalah resubstitution error rate. Okay, dia kata it tends to be biased since the data used to build the classification function are also used to evaluate the performance of the function. Kita gunakan data yang sama. Itu adalah resubstitution error rate. Nak kira macam mana nak kira error rate? Gunakan formula yang sama macam APER, cuma how to find the confusion matrix sahaja yang berbeza antara resubstitution dan cross validation. Okay, macam mana pula cross validation? It is the percentage, look here dulu, percentage of the observation in the validation data which are misclassified by the classification function. Okay, dalam cross validation error rate, to calculate this cross validation error rate, the sample will be split into training and validation data. Akan di-split kepada dua. Data akan di-split kepada dua into training and validation. Okay, training sample is used to build the discriminant function. Okay, validation sample is used to evaluate the performance of the discriminant function. Okay, let's say we have 100 of data. We have 100 of data. 50 of the data we split into two groups, which is dipanggil training sample dan validation sample. 50, the first 50 will be the training sample. We use this training sample to create ataupun to build the discriminant function. And then we want to evaluate whether this function that we built ni adalah good or not ataupun valid or not. This function is valid or not by using the validation sample. Kita gunakan validation sample untuk evaluate. Kita replacekan validation sample dia punya X dalam function yang kita create tadi untuk dapatkan confusion matrix. Daripada sini kita gunakan APER to evaluate the performance, to know how many percent of the APER. Okay, itu beza antara cross validation error rate dan juga resubstitution error rate. Okay, nak kiranya sama, gunakan formula of APR, cuma nak dapatkan coefficient matrix yang berbeza. Resubstitution kita gunakan resubstitution kita gunakan data yang sama to evaluate the function, but untuk cross validation we use the different sample to evaluate the function that we create. Okay. Okay, let's see one example. Okay, let's see one example. This example, I nak tunjukkan example using the output. Okay, later I will show you how to construct the output. But before that, I nak sekaliguslah example of the error rate tadi. And then I want to show you the output from SPSS, how we grab the information from the SPSS output. Okay, so let's say the discriminant analysis was carried out to develop the classification function for classifying the HIV patient current health status as poor or good. Okay, kita akan create the classification function. So bila ada patient yang datang, so kita boleh check dia punya current health, whether this patient with good health or poor health status. Okay, based on the support score, some results are given. Okay, so let's say this is the output from SPSS. Ini dipanggil classification function coefficient. So gunakan SPSS output, kita terus boleh dapatkan dia punya function. Okay, function of the discriminant function. Yang the second approach tu lah, linear discrimination function D tu, yang kita cari D tu kan. So here we have two group, poor and good. So akan ada dua D lah, dua discriminant function. Okay, write down the linear discriminant function. So untuk poor, so it will be D1 hat. Okay, dia punya constant here, negative 9.341 plus all the coefficient untuk setiap variables. Okay, we have 1, 2, 3, 4 variables here. So untuk D1 dan juga untuk D2. Okay, we grab the information from the output, then we can write down the linear discriminant function. So this function yang kita akan gunakan to classify whether the new patient is with good health status or poor health status. Okay, dia kata Miss A. Okay, the next question, Miss A has mean score of 3.5 for emotional support, 3.7 for tangible support, 3.5 for love support, and 3.0 for social interaction. Which group would you classify her into? Whether Miss A ni adalah come with the good health or with poor health. So we replace all the score tadi dalam kedua-dua function tadi kan. So macam mana kita nak tahu whether the patient tadi go to poor group or good group? Okay, we see dia punya score, the highest score, we observe the highest score. So just replace in the function earlier, the earlier function. So from here we can see that here 7.6634 is more than the poor score 7.06. So we should classify Miss A's health condition as good condition. Okay, kita tengok yang lagi tinggi, the highest score. Okay, the next one, calculate the resubstitution and cross validation error rate. Should we use the sample linear classification function for classifying the HIV patient? So kita nak evaluate whether the function yang kita ada tadi, discriminant function tadi, can be used to classify the other HIV patient. So from the SPSS output, we will have this result dipanggil classification results. So original ni adalah resubstitution, cross validation adalah cross validation results lah. Okay, so from here, okay, kita boleh tengok kat sini kan, ini adalah dipanggil confusion matrix. Ini confusion matrix, and total kat sini adalah dia punya total of observation. Okay, so untuk nak cari resubstitution error rate, kita gunakan formula APER, which is the number of misclassified divide dengan total of observation. So untuk original 6 here plus 39 misclassified kan, divide dengan total of 50 plus 107. Okay, tukar dalam percentage, you akan dapat 28.7. So same with cross validation. Okay, we add the misclassified items, 6 plus 44, divide total of these items, 157, tukar dalam percentage, you akan dapat 31.8%. So both of this error rate is more than 20%. So what can we say? So we can say that we should not use this classification function because both measurement of error rate is very high, which is more than 20%. So we not suggest to use this discriminant function, the earlier discriminant function, to classify the HIV patients. So that is the way how we evaluate the function, the classification function that we build. All right. Okay.